Let's talk about our first sort of classification of coupling, and that is going to be the sort of worst case scenario of coupling, and that is the idea of tight coupling. So, with tight coupling, we have a bunch of modules who are knit together, they're tightly knit together. What this means is that if we make a change in one module, we're going to have to make a change in a whole bunch of other modules to make it so the program doesn't break. This can be sort of broken up into these sort of subcategories. These are common types of tight coupling, and that is going to be in content, common, and then external. So we're going to go sort of one by one through these, and you'll see that they're very easy mistakes to make, but they can cause very large problems. The first one is with content coupling. So what this is it's when one module modifies or relies on the internal workings of another module. In this scenario, we have module A and then module B. And module A is grabbing directly from module B. It's grabbing the data right out of module B and using it for its own things. Let's say, for example, that module B, the data in question, is some sort of distance. So it's some sort of distance. Let's say in B, it's represented as meters. A typical thing that might happen. Maybe we grab it from an API, maybe it's just the way we've programmed it, but the data over here in B is meters. Well, the module A wants to convert that to miles, so it's going to take it from meters and try to convert it to miles. So all it does is it grabs directly from B, it sends it into a conversion algorithm, and then does what it needs to do with it. Now, can you see the problem here? The problem is that if someone goes in and wants to modify B, let's say we also have another one down here who's doing the same thing, grabbing B.data, maybe converting it in some other way, but it's assuming that B is going to stay the same. And that's the problem here, is the assumption that B will never change. Well, like I said, another programmer comes in here to B. He realizes that we're converting to miles all over the place. Maybe the standard nowadays is to represent all distances in kilometers. Maybe it's to represent all distances in centimeters. Even just within the metric system, you start having this ability to change things around. We could also represent all distances in miles. Let's say, though, that we just decide to change this from meters to kilometers, something that might be a very simple change. So in B, he goes in, makes the change, maybe does a little quick conversion algorithm, and now B.data, the data in here, represents meters. The problem is that you cannot see who is basically relying on that data from here. There could be 1,000 people calling, or 1,000 modules calling that little data snippet. Now, whenever we change that, suddenly all of these are going to break. A and C, and then whatever else is connected will break, because each of these was assuming it was meters and then was converting based on that assumption. So because of that, now A is going to have a problem. It's going to break. It's going to represent this weird bug where things are maybe a magnitude a little bit too large or a magnitude a little bit small. However, C converted it. It's now going to be way off. Maybe it was converting it to something else over here. So because of the change, again, it's going to be a magnitude off or indifference here as well. So because of a single change, we've now broken a whole bunch of modules, and now we have to go through each one of these modules and change them around. And again, 2 modules, not the biggest deal in the world. But if we had 100 modules, that becomes a big problem, because we're going to have to manually correct 100 modules. And we don't have blueprints to tell us which ones are broken. We just have to fix one, run it again, see what breaks, fix one, run it again, see what breaks, and so on. A better way to do this, sort of the way that you get out of this, is with getters and setters. So what this is you create this sort of interface that basically other modules can grab from. And why this is important is because if we changed meters here, we would just go change the 2 functions down here, get mile and get kilo for kilometer. So in this situation, if we change this from meters to kilometers, now all we have to do is just return that directly. Before, maybe there was like a times 10 or actually a divide by, I think, 100 to get to kilometers, and then send that out. And then a mile, there was a big equation for that. Now all we do is we change this to represent kilometers, change these 2 getters and setters, and every single one that was grabbing from this, every one that was grabbing all of these, are perfectly fine now, because they're getting the same information. We've made a single change in a single file, and everything is updated instead of having it so everything is broken. The next thing that we have right here is we have common coupling. So with common coupling, we have this idea of when several modules have access to and manipulate the same global data. So this, you can see these are all going to kind of be similar, but just a little bit different. In this situation, what we have is we have maybe a big constants file, or we have this sort of almost internal database where we're sort of storing data and taking it out. And we're doing this all from all of these modules. The problem with this is we have the ability to, for example, if this one writes to it and then this one grabs from there, and then during the process of the calculation, this one writes a new value, and this one grabs that value, and this one writes a new value, we're going to start getting these weird inconsistencies. These bugs, these sort of changes are going to be moving all over the place. So you sort of have this lack of data integrity. You don't have the ability to control the data that's coming in, and variables can start changing. And let's say that we have a little error in this one right here. So this module right here, all of these other ones are working and somehow it's not erroring out. But this one does just a slightly wrong conversion. And so when it sends that data up, it makes this variable corrupt. This variable is now there's no integrity with it. It's actually an incorrect variable. Well, the problem is because everyone's grabbing from the same global data, reading, writing, pushing, pulling, that sort of little error that this one creates is going to propagate here and 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 so on and so on. And you're going to have this problem where you're going to have a bug that's incredibly difficult to track, because the bug is going to represent itself in every single module. And you won't know that the little tiny line of code here was the error. And so that's why common coupling, having this idea of everything manipulating the same global data, is bad. If you have, for example, though, like a list of constants that never change, that is an okay time to have this sort of everyone grabbing from the same sort of giant list of constants. Now, there might be better ways to engineer a giant list of constants, but I want to sort of differentiate that as long as you're all just getting from there and this is never changing, that's perfectly fine. The problem up here is that we're all manipulating it. And if we're manipulating it, then we have that problem where tiny errors can cascade and break all the modules. So just wanted to make that little difference. The last one is external coupling. External coupling is when several modules have direct access to the same I/O. So what this is this can be an API. This could be, for example, controlling the mouse. Maybe you have a program that uses a whole bunch of modules to grab mouse data and do stuff with that. But we're going to talk about this as if it was an AI. The problem, or the API. The problem with this is if the API changes, it's external. That's the kind of the key word here. That means we don't have control over it. We have no control over how the external works. Therefore, let's say that we're working with Google. We're using one of their APIs. If we have 1,000 modules, 1,000 different modules, so we have a modules, and let's say there's 1,000 of them in here, and they're all contacting this Google API and calling a single function. What happens when Google decides, we don't like that function anymore. We're going to change it, and we're going to change it maybe drastically or maybe just a little bit. We're just going to change its output just a little bit. The problem is that now we have 1,000 modules, again, that have broken. We have to go through and change the way that our modules handle data 1,000 different times throughout all of these. And that could be a really, really big project and a big problem, especially if you're using a whole bunch of APIs, and this happens weekly. You can see the overhead that would be here. What if, though, we had instead a API controller? So we have this little controller here, and they all talk to this with proper getters and setters, and then this talks to the Google API. So Google makes a change, then all we have to do is make a single line change, and then all of these are updated accordingly because they're talking to that function that delivers the Google API. And so that's a way that you fix that sort of idea. And again, you're starting to be coupled by the API here, but it's one step better than this, and we can sort of break it down with a little bit more thought process later. But these are the worst case couplings. I hope there are more cases, of course, for tight coupling, different events and scenarios that can happen, but I hope you understand through this the problem. And the overall theme here is that we're all accessing the same data, we're writing and grabbing from it. And if we have this idea where a single line of code can break 1,000 different modules, a single line of code can even break just 2 modules, then there's probably a problem there. There's probably something that we could do to extract that controller, extract some of that information out, and fix that problem. The next lecture, we're going to be talking about the next level of this, which is slightly better, and that is going to be medium coupling.